Okay, we are ready to calculate some probabilities, particularly probabilities in situations that I'm going to call uniform. So, uniform probability experiments. And a uniform probability experiment is an experiment in which each of the individual outcomes are equally likely. So, I want to be clear here. I'm not talking about all the events being equally likely. I'm talking about all of the outcomes being equally likely, each individual possible thing that could happen. So, for example, suppose I flip two fair coins, 50-50. I have equal probability of heads and tails. So, in this setting, the outcome HH, two heads, that's just as likely as the outcome TH or the outcome TT. So I'm doing a uniform probability experiment. All these outcomes are equally likely. When we are doing a uniform probability experiment, there's a really simple formula that allows us to calculate the probability of an event. So here it is. Let S be a sample space, a space containing outcomes, and let E, which is a subset of S, be an event, whatever event. So if I'm doing a uniform probability experiment, then, by definition, the probability of the event E, which is written with a fancy P and then an E inside, is defined to be the cardinality of the event E. Remember, I'm using the word event, but an event is really just a set. And so I'm talking about the cardinality of a set here, divided by the cardinality of the sample space. So let's do a few examples in which we calculate the probability of some events. So first example, let's consider the two coin flip experiment. So recall that in the two coin flip experiment, I have the following possible outcomes. Here's my sample space. And what I'm going to do is I'm going to say, hey, let E be the event that I got 1H and 1T tails in either order. So this means that my event E contains the heads tails event as well as the tails heads event, but not the heads heads event or the tails tails event. I have to have one of each. Okay, so in this case, now I can ask myself, hey, the probability of getting one heads, one tails in either order, well, that's equal to the cardinality of E divided by the cardinality of S, which is equal to 2 divided by 4, or 1/2. So the probability of this event that I got one heads and one tails, order doesn't matter, the probability of that event is 1/2. Here's another one, another experiment with uniform probability. So let's roll two three-sided die. So I'm generating a random number, 1, 2, or 3, and I'm doing that twice. And so because I'm generating two numbers, in this case, I'm generating two numbers, my sample space is going to be a set of pairs. So I'm going to write all of them out. 1, 1 is one possibility. If I rolled both dice and I got 1. 1, 2, 1, 3. Now I have 2, 1, 2, 2, and 2, 3. Now I have 3, 1, 3, 2, and 3, 3. So those are all the elements of my sample space. Okay, so let's have my event be the event that the sum is at least 5. So that'll be my event. Okay. So what is that event as a set? Well, what I'm going to do is I'm going to add my two die rolls together and see when I get at least 5. And in this case, that happens 3 times. So I can have 2, 3, I can have 3, 2, or I can have 3, 3. Okay, this means that the probability of that event is equal to the cardinality of the event divided by the cardinality of the sample space. If you were counting along at home, there are 9 elements in here, 9 possible pairs from 3 choices. And then here there were 3 events or 3 outcomes in my event. And so I'm looking at 3 over 9. The probability of this event is 1/3. So when I have uniform probability experiment, at the end of the day, what I need to do is 2 counting problems, right? I need to be able to count the number of outcomes in the event that I care about, and I need to be able to count the size of the sample space. And if I can count those 2 things, then I can compute the probability of an event in a uniform probability experiment.